if there are no more questions here, then it is time to, by the way, today is going to be one of the most important days we are going to deal with. You must, 100%, without a doubt, be able to do this rule. Inside out, outside in, forwards, backwards. You should be able to sleep and do the chain rule by the time we are done with the first semester of the class. None of you will believe me. You will all think that my goal is crazy, but it is doable. We are going to look at derivative of composite functions, which is where we're going to get the basis of the chain rule. A composite function is the idea that we're doing two functions that are kind of inserted with each other. For instance, if I have x to the 7th and 3x squared plus 7, if I plug the g in for the x, we would get 3x squared plus 5 all to the 7th power. You've seen those before. They kind of work like these lovely things right here. The Matryoshka dolls. How many of you have seen those before? Come on, everybody's at least seen them because they're kind of fun to play with. How do I get to the third doll? You throw it in the ground. No, you don't throw it to the ground, Kevon. You have to open up the first doll to be able to get to the second doll, right? And then you got to open up the second doll, and then you finally get to the third doll. If you can understand that illusion and how it attaches to, wow, I used an English term, illusion. Oh, if you can understand the illusion I'm making with those Matryoshka dolls, this will make your life a lot easier. So, just to put things into context, if I were to ask you to do question A here, and I asked you to find the derivative of 3x plus 5 squared, you could do that. You have the capacity to do that. We would have to expand 3x plus 5 squared. What would we get if we expand that? It would be 9x squared So if I ask you to take the derivative of that, you would get 18x plus 30. That's nice. That wasn't bad, right? Now, what if we did b? 3x plus 5 cubed. No calculators. There ain't no calculators here yet. I would ask you to take that, and essentially what you would have to do is you would have to expand that, wouldn't you? Yes. Now, to expand that, you've already done the squared, right? Right there. So wouldn't you just have to multiply this by one more of those? Yeah. Let's do it. All right. So 3x times 9x squared. 3x times 30x. 3x times 25. What? 5 times 9x squared. Whoa, I wrote the wrong number. 45x squared. Because didn't sleep. Next one, 5 times 30x. And 5 times 25. So if we put that all together, we get 27x cubed. 90 plus 45 is 135x squared. 75 plus 150 is 225x, and then we have plus 125. Yeah, that's simple, right? Easy. So if I want f prime of x, what is 27 times 3? No. It's 81. 135x squared, the derivative of that. 270x, love it. Derivative of 225x. Derivative of 125. That wasn't bad. All right, so let's do C. No. Yeah. No? Yeah, give me a dry. But the problem is you're going to be expected to do a problem like that without a calculator. Since ever. So there's this concept to change things up, make things a little bit easier. We've got this idea of what is called the chain rule. What the chain rule says is, let's say I've got some function, okay? This right here, this u is a function. Be used to that because the letter u is going to be used as a variable substitute for a complicated function for pretty much the rest of calculus. If you see the letter u, it's usually some function. That wasn't even on purple. But what I can do is I can take the derivative of y. And what I can do is I can do the power rule. Because if you think about this, going back to the Matryoshka dolls, what would be the outer Matryoshka doll in 3x squared plus 5 to the 7th power? What is the outer piece? It's the 7th power, right? The 7th power is the outer piece. And so what the chain rule kind of does is to give you a visual is it says, let's take the derivative of the outside, do the entire derivative. Now, when I take that top layer off and I work with those dolls, does that change the second doll at all? No, the second doll remains the same. So when I take this top doll's head off, that sounds kind of weird, but when we do that to get to the second doll, we're in essence doing a derivative of just to the 7th power. So this would be like doing a derivative of just x to the 7th. Except instead of it being an x, we're just going to leave this the exact same. Then what I'll do is I go, okay, well now that I finished that outer piece, now I can get to the inner piece and I can take the derivative of that. Let me show you an example. Okay, right here. We're going to do 3x plus 5 to the 2nd power. Okay? Guess what? We already did that. It's right there. We've already done it. Watch what happens with the chain rule. We've got 3x plus 5 squared. Let me write that like this. So if f of x is 3x plus 5 squared, what I can do is I can see that the 2nd power is the outer piece, and the 3x plus 5 is my inner piece. So let's take the derivative of the outer piece. F prime of x is going to be, take the derivative of the outer piece. That 2 would come down, this would all stay the same, and this would go to the 1st power. What was on the inside? What's the derivative of that? 3. 3 times 2 is? Do you agree that becomes 6 times 3x plus 5? What's 6 times 3? Whoa. Instead of having to do all that multiplying and all of that stuff, I know it's kind of a letdown. I made you do all that work, and now you realize you didn't have to do it. The 3 is the derivative of that piece right here. So the derivative of that is 3. So a more complicated question, 3x plus 5 to the 7th power, can actually be done with relative ease. The 7th power is my outer piece. My inner piece is the 3x plus 5. And if I want to find dy dx, we would take the derivative of the outside, 7 times whatever was inside there to the 6th power. We would have 3x plus 5 was what was on the inside, and I take the derivative of that and get, and my final answer is 21 times 3x plus 5 . The beauty of that is that mathematicians are inherently lazy. We like rules like this because it allows us to be inherently lazy. Yay, patterns. Thank God. I am not going to do the next question because it's very similar to this one, and I'm going to be bouncing through several of the notes. I picked select questions. We are going to go through them with relative vigor. Stop me as we go if you're lost on a specific step. I'm going to rely on you to be vocal at this point in time because we have a lot that we've got to get done. So chain rule, done a little bit easier. Chain rule by definition in a textbook will say if I take the derivative of some composite function f of g of x, we would take the derivative of f, the g of x would stay the same, times the derivative of what that g would be. The idea of the Matryoshka dolls. Take care of the top piece first, then move on to the next piece. Cool? All right, let's try some. So if I look at this next piece, what is the outer piece? What is the inner piece? So, derivative of the outer piece, 5 times something to the 4th. What was that something? Times what I will typically do in these problems is I will rewrite these with the constant followed by the lowest power and then in ascending power orders. Doesn't really change any, but that is how you're going to see them organized when you take the AP test. You're going to see a constant, lower power, higher power, higher power, higher power, higher power, higher power, higher power. There you go. There's a tongue twister for when you're doing theater and all that stuff. Higher power. It's right up there with toy boat. Say toy boat as quickly as you can. That was way too slow. All right. We also have to be aware that the chain rule can sometimes give us unappetizing answers. And you won't say that when we see the answer to this. Outer piece.
2/3.
Inner piece. So we got to take care of this. The outer piece. Derivative of 2/3 is 2/3 times something of something to the. What is that something? Which means the derivative of that is and we can simplify that. 2/3 times 4x cubed is 8x cubed over 3, and that x to the 4th plus 2 to the negative 1/3. Unless it's multiple choice, then you better be able to do math. I multiplied 2/3 times 4/3, 4x cubed, took the negative exponent and shifted that down into the denominator. All right. Now, you also get questions like C. That kind of looks like a product rule, but it doesn't have to. You can rewrite that. Negative 7 times 2x minus 3 to the negative 2. Your outer function being negative 2. Your inner function being 2x minus 3. So we take the derivative. This turns out to be negative 7 times negative 2 times something to the negative 3. What is that something? 2x minus 3. What's the derivative of that? All right, what do we get? 28 over 2x minus 3 cubed. Not too shabby. We're going to skip the next one. And I introduce you to my other fun stuff. Chain rule goes great with trig. Breakfast of champions. Y'all don't seem like you're convinced of that. Cat, come on now, this is great stuff. Now, something very serious here. If you go and look at any list of derivatives that have been put out by an actual publishing house, so you get your hands on a calculus book. If you decide you want one of our calculus books at a district level and you ask down at the book room, hey, can I get one of the calculus books, which you're allowed to do. If you look in any of the Barron's or the Princeton Reviews or anything like that, and on a majority of websites, when they take the derivative of sine, cosine, tangent, cosecant, secant, and cotangent, you will notice they will not say the derivative of sine of x is cosine of x. They always do this weird u thing. Why? Because now, if I say it this way, I have incorporated the chain rule into my definition. The chain rule is so prevalent that it's actually in all of our definitions. I know. That's what I said. And then I started teaching the class. And I was like, yeah, sure, why not? That makes perfect sense. Now, just to put things into perspective, it's not that bad. Let's look at f real quick. F of x is equal to the sine of 5x squared. What is the outer function? Sine is on the outside. What's on the inside? So, just like any chain rule question, what do we have? The derivative of sine is cosine of something. What is our something this time? Times? Or 10x cosine 5x squared. We'll usually pull that 10x out front. You will eventually get better at doing these, and you will see, oh, okay, that's going to give me this term, and you'll pull that up front naturally. You are nowhere close to that yet. You will be, but you're not there yet, and that is perfectly fine. What about cosecant? Cosecant is 7x to the 5th. What is the outside? What's the inside? What is the derivative of cosecant? So it is the negative cosecant of something, cotangent of something, and that something is times (35x to the 4th), or negative 35x to the 4th cosecant 7x to the 5th cotangent of 7x to the 5th. Yeah, totally. All right. So now I can really mess with you. What's the derivative of the tangent of the sine of x? What do? Same process. What's the outside? What's the inside? What's the derivative of tangent? So it's the secant squared of something. What is my something? Sine x. What is the derivative of sine? Can I simplify that at all? Can I simplify the secant squared of sine of x?
Well, yes. He has 1 over cosine squared.
Ooh, can I though? Because that would be 1 over the cosine of the sine of x, and this is just the cosine of x. Arguments don't match. This is actually done. Just box your answer, call it a day. Folks, be careful of this. A couple things to be aware of. This is not the secant. This is not the secant squared of x times the sine of x. That's one of the first mistakes, because what do people do? They'll pull the secant down and they'll say sine over cosine is tangent. So they'll call it tangent secant. So you'll get that mistake. This is not multiplication, so you can't do that. Then or you'll get people to say, well, this is 1 over cosine, and that's cosine, so that cosine cancels out with this cosine. But the arguments are not the same. So you can't do that. You don't look pleased, Kat. I'm going to skip these following here, right here. I do want to talk about this one real quick. So this is quotient rule. This is a product rule. If you're curious what the answers are, it's negative 38 and I believe negative 9/8. If you're curious what those two answers are, but let's do this one, which is a chain rule. All right. If I want to find h prime of 3, I have to take the derivative of h. If I take the derivative of h, I notice that this is an f times the g of x. My outer function is f. My inner function is g. What is the derivative of f? F prime. So this is the f prime of g of x times all right. What am I trying to find? So I want to find the f prime of the g of 3 times the g prime of 3. What is the g of 3? 4? So what does that mean? It means we want the f prime of 4 times the g prime of 3. 8 times negative 40 is your answer. Okay, quick stopping point. Whew, because we just flew through a whole bunch of questions. How are we feeling? So far, so good? Okay, let's do some hard ones. It's so cute. Of course, to have some fun. Product rule, quotient rule, and chain rule can always be in the same exact problem. And we could have to use multiple rules in a single question. I like it. I think it's fun. But then I'm weird. For instance, I take a look at this. This is y equals x squared times 2x minus 4 all raised to the third power. Which two rules do I have to apply? Product rule, because of x squared times 2x minus 4 to the third. So this is a product rule with chain rule. Because where is the chain rule going to come into play? The derivative of the 2x minus 4 to the third power. Oh boy. So how does the product rule work? It's the first times the derivative of the... All right, so let's start that. We're like, yo, first x squared times the derivative of OMG. That's 3 and x squared minus 4, isn't it? Or 2x minus 4. So how do we do that? Chain rule, which is?
3 times 2x minus 4.
Beautiful. Go there. This is starting to look like a terrible, terrible rainbow of doom. That all goes together, thus the green bracket around them. X squared times 3 times 2x minus 4 squared times 2. That's, sure, why not? Plus! We're not done! times. Let's simplify. Box it, box it. No. Okay. If this were a free response question, you're 100% correct. I probably would have left it up here, although I may be tempted to take it here just because that's not terrible. However, well, let's talk about that. Just more product. Then you take the second derivative and you're going, I hate you so much right now. So one thing I do want to point out is you do have to learn how to play the game. For instance, in this problem, you might see an answer that looks like this. You might see a 2x factored out. And you might see a 2x minus 4 squared factored out. Which would leave us what? That would be 3x. And then this would be, the 2x was factored out, so this would be plus 2x minus 4. Or we'd call that 5x minus 4. And you might see an answer that says 2x times 2x minus 4 squared times 5x minus 4. And that might be a legitimate answer that you will see on the AP test, even say on your homework. Homework might have that type of ding on there. Hint, hint, wink, wink, nudge, nudge. If I can get back to L, I will. L is okay, let's talk about L real fast. There will be some of you that will be of the opinion that it would be wiser. Actually, how much time do we have left? We got like 16 minutes? Oh, shoot, man, let's talk about this one. No, we got time. So, some of you will be tempted to take this problem, right here, that monstrosity. And you will be tempted to take that 1/3 power and turn that into a negative 1/3 power and use the product rule. First thing I warn against when it comes to a question like that. Oh my God, are you going to deal with a bunch of negative numbers if you do that? I suck with negatives. I am not against admitting that. You may be terrible with negatives as well. If you don't like negatives, I would not suggest doing that. The other thing is on a multiple choice question, that problem right there will be done using the quotient rule, which means the answer will be written as a quotient rule, which means that after you do the problem with all of the negatives in them, you are then going to have to rearrange that problem and try to make it look like the quotient rule problem. Don't you find it much easier to just play the game and do what they tell you to do? Just guess. Don't do that. That's terrible, terrible methodology. To do this question, what we would do is this, of course, is a quotient with a chain. How does this work? Quotient rule says what? Ho-de high minus high to ho all over, ho squared. So the bottom, x squared plus 2 to the 1/3 times five. Nice. Times this monstrosity right here. So what is that going to be? To the negative 2/3. Not too bad for a, you've seen the chain rule for all of like 30 minutes and you're already doing that fairly quickly. Nicely done. We're not done yet. All over. X squared plus 2 to the 2/3. And we're not going to leave the answer looking like this. This is gross.
Squared. Box your answer.
We're not going to box the answer yet. We're going to call this 5 times x squared plus 2 to the 1/3. We're going to say minus 10 thirds x squared plus 2 to the negative 2/3 and I will let you get a second to look at that. Is this a realistic question?
No.
You bet. Of course it is. Can't. Did you say you quit band? It's the only logical choice, right?
This is why people drop out of school.
What about the very last question? So what there, Armando? Yes. In this question, this is a chain with a quotient rule built in. So in the previous question, we did a quotient with a chain. This is going to be a chain with a quotient now. So yes, the order at which we apply these rules is important. All right. So what's the outer piece? This is easy. 4 times something to the 3rd. What is that? X plus 3 times 1 minus no, x times all over just use the quotient rule. Oh no. So what is this? This is 4 times x over x plus 3 cubed times x plus 3 minus x over x plus 3 squared. The x's will zero out, and we get 12 over x plus 3 squared times x over x plus 3 cubed. Yeah. That's it. I believe we could actually take this a little bit further. Well, okay, to be fair, we could call this 12x cubed over x plus 3 to the 5th. Do you really feel like making that a little bit easier? To the 5th? You have an x plus 3 squared times an x plus 3 to the 3rd. So since you have similar bases, you can add up your exponents. Well, depends. Is this multiple choice or is this a free response? All right. Ladies and gentlemen, you have a blue packet? On your blue packet, The second sheet, front and back, 16 questions. That's yours to do by tomorrow.